Ready to go.
All right. Hello, everyone. Thanks for joining us today. And we are going to get started in just a moment. I'm going to let everyone sign in. So while everyone's logging in, welcome to Ask Mayfield Anything. This is a monthly live Q&A on technical topics. You can visit our website for past and future AMAs. We usually collect questions ahead of time and then also live. So speaking of which, I'm sure you're all familiar with the Zoom platform at this point, but just a friendly reminder, you should have a little menu bar at the bottom of your screen. There's a Q&A section. So use that to submit questions throughout this. We are recording this session right now, and we'll be posting it to our YouTube channel, and we'll send out a recap email with the video. So in case you want to go back to anything. And you can also submit just general chat in the chat feature that we'll also use to share links. So throughout this, we might mention different resources for you to check out, and we'll put the links to those in the chat. If you forget and you post a question in the chat, we'll probably remind you throughout there. And with that, I will start to go through and do some introductions here. So my name is Jennifer Alfson. I'm the Director of Business Development for Mayfield Renewables. I've been in the industry for 9 years now, and my background is as a mechanical engineer. I've worked as an applications engineer in commercial applications. I've been with Mayfield for the last 4 years now. And I do a lot of technical consulting, creating things like webinars, white papers, helping clients figure out what's the best go-to-market strategy, things like that. And joining me today is Ryan Mayfield, the founder and CEO of Mayfield Renewables. Ryan has been working in renewable energy since 1999 and founded Mayfield Renewables back in 2007. His career has blended technical expertise with an affinity for writing and education. Ryan holds a limited renewable energy technician license in Oregon and is an Oregon Solar Energy Industries Association, or OCA, board member. You would probably recognize him if you've been to the NABCEP conference. He teaches the all-day NEC course in that. And fun side note, that we learned in the last AMA session is he's also semi-obsessed with Hamilton.
Only semi. I'm getting better. So thanks everybody for joining. It's great to have everyone here, and I'm really excited about this topic. This is something I've been learning about as we've been going along. So I'm feeling like I'm going to be learning quite a bit along with everybody else. So thanks for Cherif and David joining us.
Yeah. And our topic today is beyond qualification testing and product risk mitigation. So our guests today are David Brearley. He is our very own senior project manager. So David Brearley is the former senior technical editor at Solar Pro magazine. In this role, David worked as a broad cross-section of professional engineers, worked with a broad cross-section of professional engineers, domain experts, and thought leaders. Aside from his talent for transforming dense esoteric material into accessible and engaging content, David has direct experience designing, deploying, and managing PV projects in Texas, where he also serves on the boards for Solar Austin and the Texas Solar Energy Society. So welcome, David. I'm glad you're able to join us today.
Thank you, Jennifer.
And last but not least, our very special guest today is Cherif Kedir. He is a solar industry veteran of over 15 years, spanning R&D, manufacturing, reliability, field testing, certification, and bankability. He also holds an extensive 13-year background in semiconductors. I didn't know that. I actually used to work in semiconductors also. So welcome, Cherif. Thank you for joining us today.
Thank you. Glad to be here.
What company did you work for in semiconductors? What was your role?
I started in semiconductor in here in the Bay Area with a company called Xilinx, which was just acquired by AMD a couple of weeks ago, 2 or 3 weeks ago. Did mostly test and product engineering, reliability testing, and a little bit of design, and so that was pretty interesting. I spent about 10 or 11 years there, and then I branched out into some startups, doing some unique semiconductor designs, and launched a couple of companies, and then I caught the solar bug somewhere around 2007, probably right around the time Mayfield Renewables was founded. But yeah.
Yeah. So interesting. My first job straight out of college was actually for a ceramic semiconductor packaging company, Kyocera America. So it's a sister company. Most people know the cell phones, and then there's also Kyocera Solar that does modules. So this was one of the parent companies, and that was my first introduction into really quality control, manufacturing, 5S, learned all about just processes and continuous improvement. It was a good first, I think, experience for me into the world of engineering. So diving into our topic, or starting us off with our topic today, we are going to get into beyond qualification testing. So David, you actually wrote a blog post about this, really painting the picture and setting the landscape of kind of why this has become such an important topic lately. So can you give us a little bit of an overview of why this is such an important topic these days?
Sure. Yeah, and conceptually, I mean, you can think of beyond qualification testing as a form of process improvement, and in this case, it's kind of happening at kind of a higher level, kind of within the industry. And so, in the blog, Beyond Qualification Testing and Project Risk Mitigation, I look at a couple worst case examples of project losses to illustrate the types of risks that beyond qualification testing mitigate. And first, I look at the consequences of fielding PV modules with unproven materials. And in this example, I reviewed reports of premature PV module wear out and product failures associated with a specific type of backsheet material. And while these products were primarily fielded in Europe circa 2010, 2014, we actually published a Solar Pro article on this topic as early as 2013, meaning the backsheets were visibly wearing out and products were failing within 12 to 24 months of field exposure. So, and on the one hand, the backsheet failures, premature backsheet failures can illustrate the age-old adage that the bitterness of poor quality remains long after the sweetness of low prices are forgotten. But on the other hand, all of these affected modules and all of the designs passed minimum standard product safety and design qualification tests. And that points to kind of an insidious type of project risk that has impacts that are widespread and long-lived. And so in the second example in the blog is a much more recent kind of example of a catastrophic loss that happened in West Texas in late May 2019. 182 megawatt Midway solar generating facility suffered large diameter hail damage on an epic scale. So it's an overnight hailstorm, battered kind of a 1,500 acre solar farm, resulting in $70 million to $80 million in insurance losses.
Wow.
And the Midway solar project suffered these catastrophic losses in spite of the fact that all PV modules, every PV module design must pass basic hail impact tests. And so in this case, the damages are relatively isolated, but the magnitude of the losses has widespread effects in terms of how projects are insured and how business is being conducted today, a year later. So, and I think these two examples, they illustrate that minimum product testing standards do not necessarily provide an indication of long-term in-field reliability. And that's a problem given that PV product warranty periods are 25 and 30 years. Solar projects have operational life expectancies beyond that, perhaps 35, 40, even 50 years, depending on kind of the financial model. And so the benefit of beyond qualification testing is that these protocols subject modules to enhanced stresses as compared to minimum test standards in an effort to better characterize long-term in-field reliability. And with that in mind, our special guest today, Cherif Kedir, has experience both developing and implementing beyond qualification tests. The Renewable Energy Test Center not only developed the well-known thresher test protocol, but also recently introduced a new hail durability test standard.
Yeah, thank you for that great overview. I mean, that is something that sounds like there needs to be more transparency in the fact that, okay, qualification of these equipment is one thing, but the reality is that's just not sufficient to really dictate, okay, how is this piece of equipment going to perform in real life circumstances, especially given all of these extreme weather events that have been happening. So Cherif, talk to me about what is RETC doing and what have you been seeing in terms of the changes in cell technology and module manufacturing that are affecting durability and testing?
Yeah, well, that was a great introduction by David and a very comprehensive overview of the issues that the industry is seeing right now. At RETC, naturally, we're testing products that are going to be introduced in the future. So we're not testing products that have been fielded in the field for a long time. So we always have a unique sneak preview of what's to come. And the industry has been, pretty aware of the large size modules that are being introduced with high power, ranging from 500 to 800 watts. And that's great. I mean, more power, great. Lower costs, great, especially for the manufacturers. They need to lower their costs. They need to continue being aggressive in their quest to compete with non-renewable energy sources. But that comes at a price sometimes. Just talking about the certification and the qualification programs that are required either by law, for instance, in order to install a product on somebody's roof, it has to be certified. That has always been the case, dating back decades, right? But you got to remember that just a few short years ago, module manufacturers only needed to perform a UL 1703 certification to sell their products in the US. Just to kind of give an idea of what that means, you could start the certification process with UL 1703. At the end of the certification process, the module's output could be 0 watts. Literally, they could completely die. As long as they don't start a fire or pose a risk of electrocution, we still have to issue a certificate for those modules. And those are the products that were being sold, right? And so, we always hear questions about why are we pushing the boundaries of the testing? Why do we require additional testing? It's because we have to react to the changing landscape of these modules. We can't, nobody's stagnating. Module manufacturers have to continue to innovate, have to continue introducing new products, and we have to continue assessing the risk associated with those new technologies. In this particular case, we're looking specifically at these large size modules, which are made possible with large size cells, which produce higher currents when they're exposed to the sun, generate more power, but end up creating large modules. And so for a given module, if you can just pare it down to a structural integrity issue, for a particular module that is mounted given a standard mounting means, whether it's rails, clamps, bolts, tracker rails, etc., those things are not really changing all that much, right? The frame is not changing, the glass is not changing. Well, it's actually changing by reduction. So the glass is getting thinner, yet the module is getting bigger. So a larger area is going to be exposed to the same amount of wind. And so you can just imagine a small area is going to resist the wind with this particular certain force. A larger area makes a big sail, right? Modules, like I said, are made with thinner glass. They're being impacted by the same hail projectiles that are falling from the sky. And through a lot of studies that are being published out there, at a higher severity and higher frequency of hail storms, And what we found out, to answer your question, what we found out is these large size modules are less resilient to hail impact than they used to be, right? And this is something that intuitively it may make sense or may not. It may not. So for instance, the double glass module that uses 2.5 mm glass, both front and back, has a total thickness of, let's say, 5 or 6 millimeters, right? It's a lot thicker than a conventional glass module that's 3.2 mm, that uses 3.2 millimeter glass. However, it doesn't track that way because the thickness of the front glass makes a big difference in its ability to withstand hail impact for two reasons. One, the fact that it's thinner, it has less area to be able to absorb that shock without shattering. But more critically, the thinner glass cannot be tempered the way the thicker glass can. And so module manufacturers do go through great lengths to strengthen the glass through chemical strengthening or heat strengthening, but it doesn't provide the same level of robustness to the glass that the 3.2 or thicker glass can. And that has translated into quite a few failures at a much higher rate than we ever saw before. And so this is an issue that the industry is facing, and I think it's an issue that can be solved, obviously by the manufacturers, but it's an issue that can be mitigated by the industry in general.
Mm-hmm. So it sounds like they're really just not reinforcing the actual design of the module, taking into consideration that larger area and the thinner glass. That's surprising. So I did quite a bit of in-house testing when I worked for a mounting manufacturer. So I've actually done, sandbag testing, loaded up modules. And I mean, those things, they bow quite a bit and they completely sag under. And so I'm also wondering about, even if, okay, the module glass doesn't shatter, I would imagine that there's still quite a bit of damage to the cells themselves if they're bending that much. And are there some, additional hairline fractures or damage to the cells themselves? So are you seeing that as well? Not as many, maybe catastrophic failures, but also ones that are not as visible?
Absolutely, and that's the whole point of our hail durability test program. Of course, it is much easier. It's very easy and it's very simple for anybody to see a catastrophic failure, like you mentioned. But when the modules pass, when they don't actually break, or when the glass doesn't shatter, or when the frame doesn't snap in half, then what? Historically, the tracker compatibility test, which we performed a lot of, or mounting compatibility tests for modules, or even certification tests, are very specific and they target catastrophic failures. If the module passes, it's great, everything's fine. But if you can just imagine, if a power plant comes online and on year 1 or year 2, you have a hail event, let's say, that causes a set of damage, to the modules. But what happens to the rest of the modules that the O&M team did not replace? They're just going to drive around and pick out all the modules with shattered glass, and they're going to leave everything else. And that's what we're dealing with. That's what we're trying to assess, to try to figure out which modules can withstand what type of hailstorm.
And so that brings up another good point of what, the severity of these hailstorms. So, and you touched on this, David, in the article that you wrote. Can you explain to the audience a little bit more about, why is this such a big deal now, more so now than, say, 10 years ago, with the type of hailstorms that we're seeing?
Right. Yeah. And part of it is, so I'd say to a certain extent, this is a function of the industry's own success. So historically, the insurance market never paid any attention to solar project risk, because solar projects just got kind of lumped in with these other assets, and those other assets were, required more capital to build, and so the solar was just kind of blended into the mix. And I think what has happened in recent years is that now we're seeing more and more utility scale projects are being developed and deployed. Some of the development activities are happening in regions that are at elevated risk of hail. West Texas is a perfect example, but kind of that band of hail risk you can see kind of runs through the middle of the country. And that's specifically kind of mapping the risk of 2-inch or greater hail is what that map is showing. And then the other thing that's happening is the projects are getting bigger. So the capacity of the projects are getting bigger, and the projects are more expensive. So as a result, insurers are seeing kind of more hail claims, and the value of the claims is increasing. And I think the Midway project is kind of an extreme example of that. That's maybe the single greatest kind of insurance loss the industry's ever seen. And so all of a sudden, insurers are like going, what's this thing we've been kind of blending into our portfolio? We need to kind of change the way we're looking at it. And I think the other thing that's happening that's important to recognize is that the insurance providers are also seeing claims in areas that are not traditionally at risk of large diameter hail. And so, and that's quite simply kind of an effect of climate change, it's increasing severity of weather generally, but also kind of extreme weather happening in locations that might not otherwise see it. And so outside of Texas, insurers have had to address large hail damage claims in the Southeast, in North Carolina and Georgia. And those are sort of on the boundary of kind of the risk areas kind of shown in that map, but they're not places people think of as being high risk locations. And so those large insurance losses are why hail is a hot topic today.
Mm-hmm. So Cherif, what kind of results are you seeing in these hail tests? And I'm trying to advance to the next slide. There we go. So you have been running a number of hail durability testing at RATC. So what have you been seeing in terms of the performance of these modules?
So in a nutshell, if we compare the hail test results, and this is just the results of a direct impact of, say, a 2-inch hail projectile at normal incidence, so it's hitting the module directly. And if we were to compare those results between modules that were made, say 2, 3, 4 years ago, that used 3.2 or 4 millimeter glass, versus modules that are being introduced now into the market that use a thinner glass, there's a stark difference. There's a much higher rate of failure that we see in our testing. And this is catastrophic type failures. And of course, not every hailstorm is going to have 2-inch projectiles falling from the sky. Some hailstorms have smaller, and others have much larger. And I think Mayfield did a tremendous amount of work on this topic. But what is, which is something you mentioned earlier, what is really interesting is with the modules that do not fail, it doesn't necessarily mean that they're going to be okay. And that's what you see on the right side. And so even when they don't fail, the impact, the energy that is released onto the module that hasn't caused the glass to shatter is still being absorbed by the module. And right below the glass is a crystal. It's a cell, right? Which has very similar properties to glass. And upon severe impact, those cells will shatter, they will crack. And in some cases, there are very major cracks that cause an immediate drop in performance. And in many cases, you don't see it. You see some minor cracks that you may not really think much of until you perform some additional testing, some additional stress testing to simulate the module staying in the field and not being replaced immediately after the hail event. And then, and then being subjected to thermal cycling and to a lot of weather events and wind vibrations and snow loads, etc. And then you're going to see that those cells are going to continue to degrade. The cracks are going to continue to propagate. And that's really what we're trying to assess. And that's basically the crux of our hail durability test program. Essentially what we're trying to do there is we're taking a set of modules from any given module manufacturer, and we're subjecting it to some corner cases. Have a some other cases with various severities, including a very high severity case. And those cases are not really set in stone. We're not saying, hey, you have to pass this particular hail test. There are some requirements, or some known data. There's some regions in the US that have known hail sizes as a risk to the modules, and we're going to be covering those. And what's really interesting after that is we perform a post characterization to understand exactly what happens to the modules once they've been impacted. And then we're going to subject them to some environmental testing, stress testing, which is going to accelerate the stresses and expand on those micro cracks, and then understand how those modules are going to behave after they've been in the field for a long period of time. And that's really when things get interesting. And then, of course, anytime we see that there are some cells that are potentially turning into a hotspot, we're going to drive them into a hotspot condition and see if those are going to turn into severe catastrophic hotspots that could eventually degrade or severely degrade the backsheets, or cause potential major degradations.
Right. So really taking into account not just the catastrophic failures, but then looking at, okay, how is this going to perform with all of this thermal cycling in the real world? If there's something that we can't see initially, is this going to propagate and become an issue later on? Which sounds like, that's really the level of testing that needs to be done to get an accurate, indication of how is this going to perform in the long run. So thank you for walking us through that. And we did have, and I realize I'm showing a PDF right now, and I wanted to show this video. Let me see if I can pull this up, because we have a great video showing a test that you have, but maybe you can start us off, and while I pull that up, explain what are some of the other ways to mitigate, and I think maybe this is a good question directed to you, David, of what have some of the racking manufacturers been doing to sort of mitigate this hail risk?
Sure. Yeah. Well, I think to a certain extent, you can mitigate some of the risk associated with extreme weather, and that includes everything from wind to snow to hail by adding additional support to the module. And I think the easiest example of that is when you think about what happens when projects are designed in Florida, and some of the jurisdictions there kind of have extreme wind engineering requirements that you might not see elsewhere. And essentially what that means is projects get fielded with a third rail, right? So instead of having two rails kind of supporting a rooftop system or a ground mounted system, you might have three. And that additional rail provides some mechanical support, and it's a little trickier kind of with hail, but I think the same principle does apply to a certain extent. And then and I think what Cherif can show is that there's also ways, particularly in the tracking space, to strategically change the stow angle of the modules to decrease kind of the risk.
Yeah, and here you guys can see my screen again, right? Excellent. So I'm going to play this YouTube video, and this is actually showing on the left-hand side is a standard tracker midday. So basically showing if a module is perpendicular to the hail. So if a hail projectile is coming straight at it and it's hitting directly 90 degrees, versus if you have a tracker that goes on the right-hand side showing next tracker horizon, it's saying it has a hail stow feature, meaning that they turn the module to the side. So then when the hail comes at it, it's coming and it's kind of just skidding off of it. So like that. Let's look at this video. And I think it's playing in slow motion.
Yeah, and yeah, this is great. And you explained it very well. So essentially what we set out to do, and by the way, this project was done about a year ago in collaboration with Nextracker to understand and assess their stowaway feature. So just to give them credit for pioneering this idea a long time ago. And so essentially what we set out to do is to try to understand ways to mitigate this issue that's showing up, nowadays, and assess whether, of course, it does make sense, intuitively, that if you were to deflect the impact by a certain degree, some of the energy is going to be deflected away from the module. What we did not expect, at least myself, we did not expect the, at a stow angle of, in this particular case, of 60 degrees, it took about 3x the impact energy to break a module that's in a stow position than it did when the module was impacted directly. And that also translated not just to the glass shattering, but also to the cells cracking. And so modules that did not break when impacted at normal incident had showed cell cracks, right? Which were reliability and performance concerns, and had reliability and performance, negative reliability and performance impacts. But when they're in that stowaway position, the cells did not crack, and so that was a big finding. And I think one of the ways the industry can mitigate this issue.
Yeah, and just a reminder to the attendees, we would love to answer your questions live, but put them in the Q&A section, so that really helps me sort through them and keep track of which ones we've answered. So don't put your questions in the chat, put them in the Q&A so that we can answer them here. And with that, one of the questions that came in from an audience member is are the size of the cells a factor? So if it's a smaller cell versus a larger cell, is that seem to be a factor in terms of whether or not you get cell cracks?
Not too much. So there are a lot of factors that contribute to whether cells are going to crack, and that there are so many different components there. In terms of variability, there's not just the size of the cell, but the processing. The stringing process, if it's introducing stresses, the shipping, the impact location, whether the hail impacts directly on top of an interconnect ribbon or in between. And so all of those play a role, but in general, they all tend to show the same data. Regardless of where you impact the module, it's going to yield some cell cracks or glass breaking. And of course, that tracks with the impact energy, and the impact energy is defined by the hail size, whether it's 1 inch, 1.5, 2 inches, 3 inches, 4 inches, and then the terminal velocity associated with that size of the ice projectile that's falling. And those tend to really dominate whether you're going to have a problem or not. The module construction also plays a role in general. Smaller modules with thicker glass tend to do a lot better. Larger modules, which are going to vibrate quite a bit when they're impacted, with thinner glass are going to tend to do worse. But all of the modules that we've tested showed a substantial improvement in the results when there are mitigation strategies implemented, which is in this case the only one we've been able to, as it relates to hail, the only one that we've been able to validate is when the impact is at an angle and not directly facing the module.
Got it. And another question that came in from an audience member is, do the type of mid clamps impact how the module performs? So are there any differences in the type of clamps used to hold it, or maybe how the module itself is clamped down?
To a certain degree, but not a lot. It turns out that, like I said, we did a lot of testing. There are a lot of data points with a lot of variables, and you can probably draw some minor correlations between the mounting and the results. However, the largest correlation, and that could also be non-causal correlation, but the largest correlation that we see tracks with the glass, the front, the superstrate, as well as the projectile and the impact energy.
All right. And some more, we have a lot of great questions coming in. So thank you to everyone who is submitting your questions. So this next one is from Thomas Farringer. He says, I'm a CNI installer, formerly residential. What's the real life impact on production for microfractures that are not apparent to the naked eye when optimizers and microinverters are used?
So optimizers obviously solve a lot of the problems, but so here's the issue. So when cells cracks, if they're minor cracks, very minor, you may not see the impact immediately. Over time, those cracks will develop, they'll get worse, and they'll cause the cells to operate in non-uniform manner. And when that happens, the cells will turn into hotspots because they're going to be forced to operate at a power level that is beyond their capability once they're damaged. Once that happens, what will happen is that cell will automatically trigger the diode to turn on, right? Once the diode turns on, it's going to take out 1/3 of the module. So fast forward from the time you have an issue until the time it shows up as a big problem, you're going to lose 1/3 of your module. What the optimizers do is between the time you have the event and the time that you lose 1/3 of that module and it's no longer impacting your string, that module is going to be gating the overall performance of the entire string. So if that particular module is, since they're all going to be in series, they're going to be running, they're going to be gated by the current that flows through that string. If that particular module starts to operate at say 5% below where it should be, it's going to cause the entire string to operate at that same level. Slightly a little bit, slightly higher than 5%, but but it's going to be around there. If it's 10%, the whole string is going to drop. And what the optimizers do is they will contain that during that phase from the time you have the event until the time you lose 1/3 of your string potentially. And that cell may never completely turn into a hotspot. It may just drag on for many years, just lowering the performance, and that's how you have underperformance in power plants sometimes. What the microinverter does, or the optimizers do, is they will separate that module from the rest of the string. But in the case of a hail event or any kind of event that causes cracks, usually it's not going to be happening on one single module with one single cell. It tends to hit, and impact a large number of modules in your array. And from that perspective, the optimizers are going to help you isolate the modules that are damaged more severely than others, but it's not really going to help you overall in saving the performance goals of your installations. Like I said, worst case, you're going to lose 1/3 of the module. That's 33% of expected production from that module.
Excellent. Thank you for that in-depth response. And we have additional questions coming in. Again, please put your questions into the Q&A and we'd be happy to get to them right now. So James Orenstein is asking, what are the advantages and disadvantages of thermal imaging or other visual versus electrical testing of modules in the field on an ongoing basis? So this kind of ties into what you're saying of, not being able to see these failures. What are some of the advantages of kind of doing this testing, maybe even outside of just a hail event?
Yeah, so there are plenty of advantages. The disadvantage can be boiled down into one thing, a $sign. It's going to cost money to deploy people with very expensive equipment working around the clock to find issues in the field, right? And that's okay, that's great. Now, the problem that you face is how long after the event are you going to deploy them? Probably very quickly after a storm passes, a hailstorm passes, you're going to remove all the modules that are broken and shattered and whatnot. And then you're going to perform an overall inspection of that site. Now, micro cracks in a lab setting, as you saw in the slide that was shown earlier, there are some cells there that you can hardly see that have developed cracks. Some are very major, but others may not be very major. And in that particular case, and you can see there are some cells there with squares around them that have some cracks, that may not be very, not noticeable. And this is in a lab setting in, a very high-tech electroluminescence system, right? Now, if you're trying to do that in the field, trying to do EL testing on 1,000 modules a day, sometimes working at night, it's going to be very challenging to find all of the issues. And that's what we're trying to do. We're trying to find ways to categorize products or help module manufacturers and developers and the industry in general to perform a test that's going to tell them if with this particular module, based on the results that we find, if it's fielded in an area that's only going to see a, say up to a certain hail size, you should be okay. But the value of EL and infrared imaging in the field is great, especially once there are events to assess the impact of those hail events and find all the problems that all the modules with problems in the field.
Excellent. And another question from James Orenstein. He's asking, any comments on potential induced degradation or PID failures in particular?
Sorry, I was trying to unmute myself. Yes, it wasn't a stump the speaker type question. Yes, there are. That there is no real difference in the way we perform PID testing. We still do that on every single bill of material that we test. There is a potential increased risk of PID with bifacial technologies, which we check for. But the module manufacturers have done a tremendous job keeping that under control. What I mean by an increased risk is because the PID is a phenomenon that has to do with, of course, the cell. Some cells are just PID sensitive and others have less susceptibility to PID degradations, but it has a lot to do with the glass. And so when you have two layers of glass, one on top, one on the bottom of the cell, there is a potential for increased PID risk, and we've seen that sometimes, and we've disqualified products. We weren't, those products didn't make it in the field. But in general, module manufacturers have found ways, one, to make the cells more PID resistant and durable, and two, to add additional mitigation strategies through PID blocking EVAs, et cetera, encapsulants around the cell to help slow down or eliminate the PID risk.
Mm-hmm. So that kind of leads into the same, one of my next questions was, do you see the module manufacturers responding to this issue? And, given the lab test results of how these modules are going to perform in the real world, are they starting to make design changes on their modules, frames, and the integrity of it to respond to this issue?
Yes, so the industry is reacting in many ways, in various ways. Some module manufacturers are obviously changing their designs a little bit to make the front glass a little bit thicker. Others have adopted a glass clear backsheet design strategy. Overall, the industry is still in the early stages of trying to figure out how to address this concern. There isn't a whole lot of data in the industry on all of the products. We're still in the early stages of our program, working with various developers and financial institutions and a lot of module manufacturers out there to understand their products and how they behave under various hail conditions. The design cycle is really fast in the industry. It's pretty incredible that most products, most PV modules are obsolete within a year or so, right? I mean, when you think about it, it's, I used to think in semiconductors, a product life cycle of 5 to 10 years was really fast. 6 months to 12 months and the product is obsolete and there's a completely new generation of products. That's pretty amazing. And so a lot of the changes are not necessarily going to happen on products that are going to be fielded right now, but they're going to happen in future generations of products. And what will happen now is really just to understand the risk associated with the modules that are out in the field, and we're working with many developers to do that, as well as modules that are being shipped right now out of factories around the world, and to assess the risk as well. And of course, one of the things that we do is to try to figure out in site-specific conditions and the expected hail that will likely be impacting those modules, how those modules would behave. So we don't necessarily perform all corner cases. Sometimes we just do a single case that is very relevant to a specific installation.
Yeah, and if I can just add, I think that the big challenge is that the module manufacturers are primarily kind of responding to the market's requests for continuously drive costs out of the system, right? Or to maybe improve LCOE by kind of adding by faciality, and that it's difficult to reconcile this kind of push to drive costs out of the system with the need for more durable products. And to a certain extent, I think some of the risk just gets pushed to, or some of the responsibility for kind of mitigating the risk gets pushed to whoever's kind of specifying product or kind of engineering the system, because it's at some point, I mean, some locations are inherently higher risk for different kinds of environmental stresses, for example. And one way to mitigate those risks is to specify a higher a product with better mechanical kind of characteristics, and likely that's not going to be the least cost product. And so I think I think part of what is the kind of the challenge is kind of understanding when it makes sense to pay that little bit extra up front for kind of improved kind of durability and reliability over time. And it's not going to be, and that exercise isn't required for all locations, I think, but it may be for others. And I think, places where there's a lot of snow loads or kind of extreme wind loads or hail loads, kind of hail risk are kind of fit that profile of, kind of maybe it's worthwhile kind of considering, finding a more durable product.
Yeah, and that actually is a great segue into a question that came in from our audience. Nathan Wonder, thanks for being on the line and asking your question. And I'm just going to paraphrase a bit, but are you seeing insurance companies recognizing these premium products as being more robust and being able to handle, these more extreme hail conditions, for example? Are they recognizing, the additional testing or additional product design that's going into some of these products to be able to say, okay, yes, we're going to insure this project because you selected, equipment that is going to be able to perform better in these circumstances?
Maybe I'll start and I'll hand it over to David. I think he'll probably have a lot more insight than me. But what we found out, and it wasn't too surprising, is the insurance industry is extremely interested in what we're doing, because, and so are the developers, because, as David mentioned, after the $70 million claim in Texas, there was an overcorrection by the insurance industry. It became a huge problem for them, a huge liability to cover hail. And I've heard in some cases when developers insisted on covering hail, the premiums were just extravagant enough where nobody could, would be able to do it. And now what we're seeing and what we're working with various insurance underwriters and brokers is to understand what all of this testing means, what all the risk mitigation strategies do, and how all of those fit into an equation of reducing losses or the risk of losses in such events. I don't know of a particular insurance company that has started underwriting based on our tests, but we talk to them on a regular basis, and they're very engaged in understanding what we're doing. And I think David probably has a lot more insight there as well.
Yeah, I think I can add to that somewhat. And I think what's sort of interesting when you look at it from the insurer's perspective, and I had the opportunity to interview kind of some subject matter experts for a project, and so one of the things is the insurance industry inherently is very data driven, right? And so part of the challenge is ensuring solar projects in general is that particularly large, many 100-megawatt kind of scale projects is that it's a relatively short period of time that they've been in the field. So there isn't like a long history of kind of data to go back to assess and kind of understand risk. And when it comes to these kind of targeted responses, the insurers are super interested in kind of understanding like how they work and kind of what the impacts might be. But they also want to see the data, and not necessarily even, I think, data from the lab is one thing, but I think they want to see like the data from the field that it's working. And the insurers are they're sophisticated enough that they understand that products are changing on a continuous basis. And so the product, like they might get a snapshot of what kind of risk looks like in projects today, 5 years from now, but 5 years from now, that's not the products that people are going to be fielding. And so I think I think it's a little bit of a challenging nut for them to crack from that perspective. And I think the other thing that's interesting from the insurer's perspective is that obviously the high cost, like the high value in the claims is associated with kind of module damage. And so, and I think there's a little bit of, I don't think skepticism is the right term, I think that the insurers just kind of acknowledge the fact that it can be difficult for other parties, say a tracker manufacturer, to solve a problem that is intrinsic to the module, if you follow. And it's just sort of interesting, and those are some interesting things I've gathered from talking to insurers. And yeah, it's not an easy thing to solve, but I think they've also acknowledged that if they see evidence that a certain mitigation strategy works, they absolutely change the way that they kind of underwrite projects.
Mm-hmm. I'm curious how an insurance claim would actually happen for a hailstorm in terms of how are they going to verify, oh, there was hail this size that came down and the frequency of it? Do they rate hailstorms in a certain, how would that work out in terms of saying like, does an insurance company just say they're going to cover the system regardless of what type of hailstorm rolls through, or are they going to cap it and say, okay, if it's a hailstorm past this level, we won't insure it? Is there a cutoff for that, or is it more open-ended?
Well, I'd say, I think the simple way that they kind of address it is to just have a kind of a sublimit, and you think of like a homeowner's policy where there's sort of like a umbrella policy, but kind of within specific categories, and it might be flooding, or it might be, I don't know, tornado damage, or that they'll say we'll insure damage associated with hail up to X amount of the project valuation. I think that's typically I think that's the most common response today to kind of the hail problem, is that the insurers are just capping the damages. And to
a dollar amount rather than qualifying the actual event.
Yeah, and I know for a fact that at the Midway project, essentially there was no cap. I don't think there was a cap on the limits, and so the insurers were replacing the modules that had broken glass, but they also had third parties out there doing kind of in-field EL testing and kind of evaluating like what percentage of modules in each of the blocks were returning kind of these signs of kind of damage, and and making a determination based on kind of a certain statistical analysis of where they were going to replace modules that didn't necessarily have broken front glass. And so it's not like all of the modules at that site did not get replaced, but effectively, I think it was something like all of the modules kind of south of a road that bisected the plant got replaced, roughly is kind of how that all shook out. And
Yeah.
and kind of when those third parties were going through and kind of doing that detailed testing, the closer they got to that road, like the lower kind of the you know, the failure rate that they were seeing in the EL test results.
Yeah.
I've got
So
one. I've got a
we
question,
have,
Jennifer. Real
okay,
quick.
and I do want to be mindful, we have about
Yeah.
4 minutes left, but if everyone's fine with staying on a little bit longer, if anyone does need to jump off before we wrap up, just a reminder that we will be sending out a recap email of this recording. And then we also have another AMA coming up in January on energy storage, specifically AC coupling versus DC coupling. But we're going to keep answering questions because there's still some great questions coming in live. So Ryan, you were going to say.
Well, I just wanted to, I'm thinking of this, thinking of this Midway project, quite a large project, but I'm thinking of as a designer or as a commercial installer, what are the, if there's good questions I should be asking my manufacturer, my supplier, are there easy ways to know if there's been beyond qualification testing done? How can I assess the products? Everything has a UL listing, so that should be great. But as we're learning here, that's not, that's a C-. And so we want to find what can I get, how can I get a better product? So how do I know what questions to ask? And hail versus snow loading versus wind loading, every region in the country might have something a little different. So I guess my question is, how do we learn what we don't know?
Mm-hmm. Yeah, that's a good point, because on most data sheets, it just says like, oh, pass this qualification test and that's it. They don't generally put more than that on a data spec sheet. So how would someone evaluate, what equipment is going to actually withstand the application it's being put in?
Yeah, and so there are 2 points to that, at least in the our recent engagements for the past few months. One is the assessment of the product and how it's going to behave under certain conditions, and 2, defining the boundary conditions. And so, for instance, if a project is going to be installed in somewhere in Colorado, we did a project there, and based on extensive research by the developer and some experts, they found that the maximum hail size that site would be seeing would be roughly 1.5 inches. That's how they defined it. And so in that particular case, at least your boundary condition. And that's what the insurance is going to be looking at, in my opinion, and David would know more about this. But if you were asking an underwriter to provide you with coverage on an installation where it's expected to have 3-inch hail or 4-inch hail, the likelihood of catastrophic damage is extremely high. And I think it's going to be very difficult to get that coverage. And so, what you're trying to understand now is, okay, well, what about somewhere between 2 inches and 3 inches, which probably makes up a vast majority of hail-prone regions? Then our program seeks to understand for that particular boundary condition, how will the modules behave in terms of catastrophic failures when they're first subjected to impact, and 2, in terms of long-term degradation caused by cells cracking and being subjected to years of wind and thermal cycling. That's basically what we're trying to assess here. And when you have all of that data, it helps you gauge the risk associated with that particular installation, coupled with the module that you're looking at. And I think, and hopefully that provides enough confidence level to the insurance industry that it's low enough of a risk for them to cover it with a reasonable set of premiums.
Mm-hmm. And so another question that came in from James Orenstein is, and maybe David, you can speak to this, is, Nextracker has their hail stowing capability. Do you see that, and they are promoting that as a risk mitigation feature for high wind and also hail events? Do you see that as being an industry trend for other tracker companies and other racking manufacturers to start taking these things into consideration?
For sure, and you can see that particularly with the kind of high wind areas. I think the industry, before hail was kind of the the big topic of discussion in terms of like large project losses. I mean, most of the big project losses were associated with high wind events, and so a few years later, pretty much all of the major tracking manufacturers have a way to kind of mitigate those risks. Some of them are doing it by kind of a defensive stow position. Others, I think ATI has sort of a system. It's a passive system where the modules sort of come decoupled from the structure, and it kind of takes some energy out of the wind that way. So it doesn't transfer all of that energy into the mechanical system. And I think what'll be interesting is to see how effective some of those kind of different architectures and kind of different strategies are at mitigating different types of risk. So because the Next Tracker product is relatively unique in terms of sort of it being kind of these individually controlled rows that they can move into a defensive stow position, even if like AC power is lost, all kinds of things like that. And they can, in some cases, automatically kind of enter into the stow position, kind of based on local sensor kind of results. And I think all other manufacturers, I think, will be following suit. And it'll just be interesting to see kind of whether kind of some of these different kind of tracker architectures are how they adapt to like being these gang road systems are a little trickier maybe to move an entire 100 megawatt plant into a defensive stow position than an individually independently controlled system.
Mm-hmm. So another question that came in from our audience is, in accordance with the module manufacturer instructions, modules can be mounted in landscape or portrait. So are you seeing in the testing, is there a difference? Is one better than the other in terms of impact resistance to hail?
Not when it comes to hail. It doesn't have a huge impact on, or at least I should say there is no high correlation between the mounting direction versus hail durability. But the mounting, related to the module technology and extreme weather events, it does impact the wind and snow load resistance. And so that's something that definitely developers should keep in mind when they're installing these modules in high or severe weather conditions.
And I'm assuming landscape performs not as well in high wind conditions versus portrait?
Yes, and it depends on the, correct, you're absolutely correct, and both wind and snow load. And it depends on the clamping mechanism and the location of the rails. There are so many ways, racking manufacturers have designed their products to reduce costs and reduce the number of clamps. And there are, in many cases, there are some modules that are clamped together. They share clamps, etc. Those are all weak points in there. Of course, for temperate weather installations, it's really not a big deal. They do extremely well. But for severe weather, they are a risk that should be assessed and evaluated.
Mm-hmm. All right. And the very last question that came in from the audience is, although hail is tested, are there ever any warranty claims due to hail rather than insurance claims?
Yeah, well, that's kind of an interesting thing, because it's tempting to say, well, if there's obvious hail damage, well, it's going to be difficult to get that through as an warranty claim. But if you have, and this actually goes back to one of the things I thought it'd be interesting to ask Cherif is so we know as part of the basic product qualification testing and safety testing, modules have to withstand the impact of more than 10 1-inch hailstones. So so there's a test kind of designed, an impact test designed to simulate that. And I'm not entirely clear what the the pass-fail criteria looks like after that. I mean, are you looking at how do the cells perform after they've been kind of put through kind of some thermal stresses, or is it just a matter of whether the glass breaks to kind of pass that test, Cherif?
Yeah, so as it comes to when it comes to actual certification, and maybe that's actually a really good topic to mention at the close. So in order for module manufacturers to certify their products to be sold worldwide, I mentioned earlier UL 1703. Now there's a new standard which has been harmonized with IEC, which is a lot more rigorous, and it has a maximum degradation limit for all of the tests that are performed. When it comes to hail, IEC actually has a table in it, and it states various hail sizes ranging from 1 inch to 3 inches. However, there's no requirement that any module should pass anything other than the minimum, as long as you perform a hail test. And that's what you mentioned, David. Shooting a module 10 or 11 times with 1 inch hail, within 1 inch projectile, and then measuring the performance degradation. So what we do is we perform the impact, and we perform a maximum power measurement and we measure the degradation. If it's less than 5%, it's a go. You get a certificate. Now, the interesting part there is we've been doing certification testing for 11 and a half years. And before that, I did it, as a manufacturer before we started RETC. In my experience over the last 15 years, I have never seen a module break with 1 inch hail impact ever. And so to me, it's just, it's a test that's performed because it's a requirement by the standard, and that's it. And that's why for the past 8 or 9 years, we've been doing 2 inch hail testing. So this is something, even when it wasn't a big event on old modules, previous generation of modules, especially for utility scale modules. If you remember, they were all made with 4mm glass. It was it was just a non-event. There was no issues there, but we still continued doing them, and we still found issues either at the cell level or on the glass from time to time. But yeah, so from that perspective, unless the module manufacturer clearly provides a warranty letter that states that those modules would withstand a particular hail impact, say 2 inches, 3 inches, or whatnot, I don't think it's possible to invoke a warranty claim. So that's something that I think would have to be clearly spelled out and reviewed in the engagement collateral, especially the warranty part of the contract with the manufacturer.
Right. So read the fine print in the warranty, because if it says, oh, warranty covers hail, the chances are the type of hailstorm that it's going to cover is probably not going to be the type that's going to cause a ton of damage. So likely that the events that are going to cause significant damage are not going to be covered under warranty.
Yeah,
so with that, oh, go ahead.
Yeah, I just tagged that because I think that's exactly my thought. So you can kind of imagine like a scenario where there's big enough hail that it wouldn't break the glass. And so like maybe down the road, you have sort of a warranty claim kind of based on loss of power. And I think everybody knows that that's a very difficult claim to litigate. It's very difficult to prove. And I think and particularly at scale, right? And I think if you were going through the process of trying to get a third party out there to prove that your installation kind of met this kind of loss of power criteria such that the module should be replaced under warranty, that analysis would probably reveal the fact that that there was cell cracking, that indicated some sort of stress that would be considered abnormal, and maybe by the pattern they might be able to tell that it wasn't like installers standing on the modules, but it looked like hail. And so I think it's difficult to understand. I think it's difficult to imagine a scenario where you could be able. You certainly can't rely on the fact that a module manufacturer is going to kind of replace product under warranty after it's been hit by hail.
Yeah, good points to note. So we are 10 minutes past the hour. I want to thank everyone for participating today. Thank you so much, Cherif, for joining us, and David as well for educating us more on all of these risk mitigation testing. Just a reminder to the audience, we are going to be sending out a recap email with the recording of this. And next month, our topic is AC coupled systems versus DC coupled energy storage systems. And we will have our very own Justine Sanchez on the line, and Ryan speaking about energy storage systems and design considerations. We also are offering some new workshops. So Ryan, maybe you can speak to this a little bit of what do we have coming up in 2021?
Yeah, so 2021, Justine and I have been working on this quite a bit. And so we have these quarterly workshops focused on energy storage systems, both residential, commercial projects. And so we're basically segmenting the different design aspects, code aspects, available products, those kinds of things. We're segmenting those out into workshops for individual companies is what we're looking to do. And so diving deep into those topics and working with your teams directly on those. So yeah, exciting new things for us here.
Excellent. So it looks like, it's 2 workshops per quarter, is that right?
Correct.
So
yeah, correct.
Excellent. And are they available for NAPCEP credits?
And yes, NAPCEP credits available on all those. So any of your installers or any of the folks on your team that have NAPCEP certification, we'd be able to get CEUs for all those classes.
Excellent. So reach out to us if you are interested in these workshops. You can really email any of our email addresses. We'll route your email to the right person, but education@mayfield.energy is how you'll for sure get connected with Ryan and Justine. And there's our contact info on there. So thank you again for everyone joining us today, and have a great rest of your day.
Thanks, everyone.
Thank you.